Okay, continuing with the conclusions, we will now go to the next conclusion, number 4, where we will discuss types of FM. So there are two types of FM. One is called wide band FM, which is WBFM, and the second one is called narrow band FM. So we have two types, wide band FM and narrow band FM. We will have a detailed discussion on the comparison of wide band and narrow band FM. As of now, all we can try to understand is in wideband FM, we will be transmitting more number of sidebands. So when I say more number of sidebands, with what I'm going to compare the number of sidebands. So it is the number of sidebands that we transmit in narrowband FM. Let's write down the expression of narrowband FM, and then we will come back to the number of sidebands that we transmit in each case. So in case of narrowband FM, without worrying about how much power I'm transmitting, how many number of sidebands I need to transmit as per the Carson's rule, without worrying about those things, we very strictly define narrowband FM to have only two sidebands around the carrier. So if I write down the expression of narrowband FM, it comes out to be something like this. The first term was J0 mu f into cos of omega ct, where J0 is the 0th Bessel's function, minus the second term was minus 2 J1 mu f into sine omega ct into sine omega mt. So this is the expression of the narrowband FM. The remaining all the terms we are neglecting, we are removing them from the expression, and hence I'm saying that there are only two sidebands present. So I can further write the expansion of this as J0 mu f into cos omega ct. Now this, we are already expanded this, it comes out to be, I'll keep minus sign outside, it's J1 mu f into 2 sin A sin B, comes out to be cos of omega c minus omega mt minus cos of omega c plus omega mt. So that's the expansion I get. So if you now observe, the first term represents the frequency fc, this represents frequency fc minus fm, and this represents frequency fc plus fm. So even if we had a practical modulating signal, instead of having discrete frequencies, we will have a frequency band that will go from fc to fc plus fm, which we will be calling first upper sideband, and fc to fc minus fm will be calling it first lower sideband. So there are only two sidebands in case of narrowband FM. So we only transmit two sidebands, and because we transmit only two sidebands, bandwidth of narrowband FM is 2 into bandwidth of one sideband, which is FM, so it is twice FM. So whenever we are given a narrowband FM, we will not use Carson's rules to calculate its bandwidth. Narrowband FM will always have the bandwidth of twice FM. We make a conclusion saying narrowband FM will transmit only two sidebands. We remove all of the remaining sidebands. This will obviously result in more power loss and hence more amount of information loss compared to wideband FM. In case of wideband FM, whatever FM that we have discussed till now, we will simply call it wideband FM. So in wideband FM, we would want to transmit more number of sidebands, and that will be as per the Carson's rule of bandwidth. So what will be bandwidth of wideband FM? It is same as the bandwidth given by the Carson's rule. But for narrowband FM, the bandwidth is simply twice FM, and hence narrowband FM also becomes very much similar to double sideband full carrier, because you can see you have the carrier term present and you have the two sidebands also present this time. So in terms of frequency spectrum and the bandwidth, narrowband FM and double sideband full carrier signals are very much similar. Both have the bandwidth of twice FM. But if you look at one very important difference in terms of mathematical expression, when we had written the expression for double sideband full carrier, when you take form of the carrier as cosine function, in case of double sideband full carrier, you have the same form of the carrier. You have the same cosine form appearing in the second term also, which is not happening in narrowband FM. In narrowband FM, you can see that when you have cosine form of the carrier taken here, you can see that the term of the carrier which appears, the form of the carrier which appears in the second term is sine omega ct. So there's a 90-degree phase shift that has taken place in the carrier form from cosine to sine.